Hi everyone, welcome to your Play Posit for the week of September 12th. We are starting Unit 2. I can't even believe it. Go ahead and grab your notes and we are going to get started. So today we are going to be starting our journey in solving equations. This is something that is not new to you all. You've been solving equations since first grade, maybe even kindergarten. My daughter's in second grade now, and she was solving equations in first grade. And it was so funny. She came home telling me about it, and I was like, "You're doing algebra!" And she liked that at the time. So we are just going to build upon what you've already learned in solving equations. And by doing that, we're just going to recall what does it mean to solve an equation, finding those missing variables, checking our answers, and we'll look at identifying key components in a real world problem. We're not going to do number 5 today. We've already done that. So when we're solving these equations, most of them right now are linear equations in a straight line. We are going to get to some equations that are not lines. Those are called quadratic functions, and they are curved. So that's going to be something new for you this year. But linear equations are everywhere. Well, we know, I think, all math is everywhere. But I want to share this link with you all. I'll put it in the Play Posit, and it's an article that you can read with a bunch of different examples of linear equations in the real world. And I want you to create just a quick slide showcasing an example in your world of a linear equation. If you would like to participate in that, it is due to me via email no later than the 23rd. That's next Friday. You have 2 weeks. It shouldn't take you very long. But regardless, I want everyone to spend some time reviewing this website. So if you want to review it, get some ideas and send me a slide. I'll show you an example from 2 years ago. A student made this and she actually plays tennis. So this is kind of what spurred her idea. And she found that you can actually apply linear equations to calculating the trajectory or trajectory of the movement in the ball and how far it's gone, depending on force, speed, and height. And you can see her example here. So this is a linear equation. So for the extra credit, you want to have a narrative like this. An image would be great. And then, of course, your equation. So those 3 things are what you'll need to get those full extra credit points. So let's recall inverse. Inverse, in my mind, I always think of the opposite. But that's not always true. So we're going to talk about math inverse. And I love this image because it looks kind of like you're looking in a mirror. You're kind of seeing the opposite, the reflection there. So I know that you all, like if we were live together, you would just be throwing these in the chat box. So we know the inverse or the opposite kind of addition is subtraction. I'm just going to write this symbol. The inverse of subtraction is addition. Multiplication, our inverse or opposite, is division. And division is multiplication. Remember, multiplication can be a dot. This is so funny how multiplication has so many representations. It can be an X. It can be the asterisk. Another thing multiplication can be is just like a number next to something, like this. That's another, like 5. That means 5 times 10. So many ways to write multiply. The inverse of a fraction is actually the reciprocal. And I like to think of this as the refliprical because you're going to flip the fraction. So for example, if you have 1/2, the inverse of that is going to be multiplying by 2 over 1. If you have 2/3, negative 2/3, the inverse of that is going to be multiplying by negative 3/2. So you're just flipping the fraction. The inverse of squaring, so something like x squared, the inverse of squaring is square rooting. And similarly, the inverse of cubing is cube rooting. We're going to do a lot more with squares and cubes this year. Don't worry. Don't worry. We're going to take it a step at a time. I know that you're OMHS lessons do a really good work at this, so make sure you're going through every part of the lesson, taking your notes, practicing the problems, because it's all pretty much the same, but they all look a little different, right? So like the process is the same. All those inverses never change, but all of the different problems kind of look like, oh, you might have to start here, you might have to start there. So practice definitely helps with these so you can get used to all the different kinds of problems you'll see. So that's what we're going to do. We're going to do a bunch of practice. We are going to solve them and check them because this is, I mean, we can do it a lot in math, but this is a really good time where you can check your work and you can make sure that you got it completely right. So the goal in solving equations is always to get the variable by itself. And in this case, the variable is x. So we're going to leave x alone, and we want to get rid of everything else that's with the x. So minus 5 is with the x. So when I say get rid of it, we're going to move it. So we're going to move it to the other side of the equal sign. And this is what you guys have been doing for years. My daughter even on her second grade worksheet, she's balancing equations. So you may remember seeing like scales. Let's see if I can draw a scale. That's not terrible. And we want to balance the equation, meaning whatever you do to one side, you have to do it to the other to keep that scale balanced. If we only added 5 to one side, it would be very imbalanced. So whenever we're doing the inverse, you have to do it to the same thing to both sides. So this is minus 5. Remember the opposite or inverse is addition. So we'll just bring our x down and negative 5 plus 5, well, that's 0, right? And that's the whole point. That's like the beauty of inverse is we wanted to get rid of the 5 so that way we could have x by itself. Bring down your equal sign, and 12 plus 5 is 17. We did it. We got x by itself. Now check it. That means you're going to plug x back into the original equation. Is 17 minus 5 12? And you can use your Desmos, and it is 12. I can't even tell you how many times myself as a student and as a teacher has made tiny little sign mistakes or adding mistakes, and I catch them on my check. So trust me, check it. Number 2, we are trying to solve for z now. So we're trying to move our 7. This is a plus 7, so remember the inverse is minus 7. You can use your Desmos at any time. I usually put a line through my z so it doesn't look like a 2. 3 minus 7, that is negative 4. And we're done. Let's check it. We're going to plug negative 4 back into the original equation. Negative 4 plus 7, is that 3? And it is. And you can even use your Desmos if you're like, well, I don't know. I can't really remember. Negative 4 plus 7 is 3. All right, our next example. So this time we see the variable or the letter on the right-hand side. That's totally fine. Don't let it scare you. The goal is the same. We want to get the variable by itself. I really want a different color, but sometimes when I start to do stuff, I feel like I'm going to mess it up. Yeah, I'm afraid. Okay. So what's with the variable? 3/4. That's a fraction. Remember, our inverse of a fraction is the reciprocal or the refliprical. So we are going to flip the fraction and multiply by that. So we're going to multiply by 4/3 on both sides. You know what? Let me just rewrite that. Okay. Okay, we're going to multiply by 4/3 on both sides. Still have to keep it balanced. Again, you can grab your Desmos, or let's review how to do it by hand. There's kind of 2 ways to do this one over here on the right-hand side. 4 times 3 is 12. 3 times 4 is 12. 12/12 is 1. And remember, that's the whole point. We wanted to get n by itself. Now, I say by itself because it just has a 1, right? 1n is just n. So over here on the left-hand side, whenever you have a fraction, I think it's easiest to make them both look like fractions. So I'm going to put this over 1. Then we have 4 times 4 is negative 16. And 3 times 1 is 3. So we are left with negative 16 thirds. Make sure we didn't make any mistakes. I've been known to do it, and I wish you were here to be my support, my error analysis support crew. Okay, so we can check it. Put a line here. Let's plug in negative 16 over 3. Oh, this is okay. So now I'm going to kind of show you that other way. Over here, we could have gone like this. 4 over 4 is 1. 3 over 3 is 1. Just like here. 3 over 3, those cancel. They divide out. So you're left with negative 16 on top and 4 on bottom. Sure enough, negative 16 divided by 4 is negative 4. So it does check. I always write a smiley face when when I get it right. And this is, again, I'm just going to keep telling you how important that check is because you get a fractional answer and sometimes we think like, wait, that can't be right. Miss Winslow would never have given me one where you get a fraction or a decimal, but you can because that's more real world than whole numbers, really. And you can see we checked our work and we got it right. All right, let's look at number 4. Here's our variable. So what do we have with it? We have a 5 times x. The inverse or opposite of multiplication is division. So we're going to divide both sides by that number. You get x equals, now we could use our Desmos or do it by hand. I'm going to do all these by hand because you can just grab your Desmos link and do it. So 5 into 21 is 4. 5 into 10 is 2. So we get 42. Okay, let's check it. We're going to plug in 42 for x and see if that equals 210. Grab your Desmos if you want and type 5 times 42. I'm going to do it by hand over here. 5 times 2 is 10. 5 times 4 is 20. Plus 1 is 21. There it is. It's correct. I love that part. Excuse me. Okay. Now, we have some multi-step equations. But remember, I said they can just start to look a little different, but the steps are the same. The goal is to get the letter by itself. So I always kind of square it or circle it. And we have to get rid of everything else that's with the letter. Now, this is really important because this one's a little different. We don't want to start with the 6. No, no, no. And my analogy is think of a tree. And let's say you were going to cut down this tree because it was, I don't know, it was going to land on a power line. It was dangerous. Danger, danger. So somebody hired you to cut this tree down. It's an apple tree. Don't worry, you'll plant another one over here. A little seedling to make up for it. And in order to safely cut down a tree, you first need to remove all the low-hanging branches. Anything that's kind of sticking out there, you remove those first. And then you go for the larger branches. And then you go for the trunk. You're not just going to cut that trunk down and have all these flailing parts. It's not safe. I know this because my stepbrother has cut trees down before, like for a profession. And we used to live on a property that had a ton of trees, and someone came down and professionally cut them for us. And I was talking to him. So this is real. So you can think of this equation like you're chopping down some trees. Don't forget you're replanting over here. Promise. So let me just finish my picture. Hold on. Okay. They need sunshine and maybe a little rain. So before we can hit this branch, we have to take care of this apple, if you will. It's what's hanging out, hanging over there, out off of the variable. That's what you have to move first. You have to. You can't touch anything with the letter until you get rid of all the apples and low-hanging branches. So this is a -5. We're going to add 5 to both sides. Bring down the big branch, and 31 plus 5 is 36. Now it's safe. There's nothing hanging out, poking out, going to hurt you when it falls. Now we can go ahead and get the variable by itself here. This is -6 times n. The inverse of multiplication is division. -6 divided by -6 is 1. 36 divided by -6 is -6. So let's check it. We're going to plug in -6 everywhere we see an n. And you can use your Desmos. How many times did I say that already? All right, so -6 times -6 is 36. Is 36 minus 5 31? Sure enough, it is. All right, this challenge, I want y'all to try this on your own and come back for the answer. We'll go over that in live class together. Okay, we have another tree to remove. This one's rotting. We'll replant, don't worry. So before we can do anything with this term, we have to get rid of this apple that's hanging out over here. So this is a -6. We have to add 6 to both sides. -6 plus 6 is 0. -12 plus 6 is -6. Okay, now it's safe. So I see a fraction, hopefully y'all do too, and the n is on the top. Well, what's in front of the n? What is always in front of the variable, even if it's not written? There's always a 1. So really, if you want, you can think of this as 1n over 3. Those mean the same thing. So sometimes that's helpful when you're trying to look at the reciprocal. So we're going to multiply both sides by 1/3 flipped. So 3 over 1, 3 over 1. Now the beautiful thing that's going to happen over here on the right-hand side is these all divide out to be 1. And you get that n. Isn't math kind of cool? Like, I know y'all probably think I'm crazy, but this just goes back to like, who ever thought of this? Like, it just seems very magical to me sometimes. I know people say like math magic, or I've seen a mathematician or a math magician before. Pretty magical. It's very cool. All right, the top is 3 times -6, that's -18, and 1 times 1 is 1. So we get -18. Check it. Don't forget to check it. I'm telling you, we make tiny mistakes that we can catch in our checks. So I'm going to put in -18 where n is, and let's see. Use your Desmos. -18 divided by 3, that is -6. Is -12 the same as -6 minus 6? And it is. Remember, I don't know if y'all remember KFC, keep, flip, change. So keep the first term, flip the second sign, change the second sign. So this is -6 plus -6 is -12. If you forgot or you're feeling stressed out, grab your Desmos, type it in. Y'all have reached a level of mathematics where you use your calculator as a tool. Use it. Use the tool. Oops, I think I just moved that slide. There we go. Okay, next tree. I don't think I've ever stuck with that analogy for as long as I have this year, but I like it. All right, we're going to leave this term alone until we can get rid of the +4. So the inverse is -4 or -4. Bring down the truth there, it's x. 8 minus 4 is 4. And we have that fraction, so we're going to multiply by the reciprocal, 3 over 2. Remember, these divide out. 3 over 3 is 1, 2 over 2 is 1, and you just have x. Over here, we can put this over 1 if it helps. I think it helps visually because I'm going to do 4 times 3, the top times the top, and the bottom times the bottom. So x is 6. Don't believe me? Let's check it. We're going to plug in a 6 everywhere we see an x. Over here, 2 times 6 is 12. 12 over 3 is 4. We're remembering our GEMDAS, our PEMDAS, right? Division first before addition. And 8 is 8. I love it. It's like the best problems because you get to check your answer. Okay. Check this one out. Here's the variable. It's kind of stuck, right? It's like stuck and attached to that 6. Stuck up there on the top. And so we have to like release it, get it off from the top and get rid of everything else that's with it. So we have a fraction here. So first we're going to multiply by the reciprocal. So you can think of this as 1, right? 1 over -4. Well, let's flip it. So these will divide out, the 1's divide out. Oops, do it over here, don't forget. And now you're left with just n plus 6 on top and 10 times -4. Doesn't that look so much better? All right, now we can get rid of the 6 by subtracting it. And n is -46. So let's check it. We're going to plug in -46 and see if it equals 10. I hope so. -46 plus 6. Check it on your decimals if you want. That's -40 over -4. This is looking promising. Negative divided by negative is a positive, and 40 divided by 4 is 10. You can do your happy dance, and you are feeling confident that you got the question correct. All right, now we're moving into something a little different, but the same. Do y'all remember absolute value? So absolute value are these vertical bars here. So let's see if we remember. What is the absolute value of -5? It is 5. So absolute value is always positive after you take it. So you can see like the number inside of here is -5. So the number inside can be negative, but when you take the absolute value, it's always going to be positive because the definition of absolute value is the distance away a number is from 0. So if you look at a number line, here's 0, 1, 2, 3, 4, 5, here's -5. How far away is it? How far? The distance or the length? It's 1, 2, 3, 4, 5 units. Just like 1, 2, 3, 4, 5, +5. +5 is 1, 2, 3, 4, 5 units away from 0. That's the definition of absolute value. How far away is it from 0? And distance is never negative. Length is never negative. It's always positive. So even if you have a negative number, like -5, if you're talking about the absolute value of it, it's always positive because you're talking about the distance it is away from something, from 0. So that kind of alludes me to question 2 here. Is the absolute value of -3 the same as 3? It is true. The absolute value of -3 is 3, and the absolute value of 3 is 3. Remember, absolute value, once you take it, it's always positive. And just like we saw up here with this number line, whether it's -5 or 5, they're the same units away from 0. Just like 3 and -3, they're going to be the same units away from 0. 3, right? 3 units. So this is true. And this is really important because it's going to help us solve absolute value equations like this one. So how about this? So now we have a variable on the inside of the bars, the absolute value bars. Remember earlier I said, and we saw, that whatever's on the inside of these bars, it can be positive or negative. Remember we said the inside value, just like we saw here, the inside value was negative, the inside value was positive. So it can be either or. So whenever we're solving an absolute value equation, once you have the absolute value all by itself, we're going to write some steps. Absolute value, and you should write these down, all by itself, which we do. The absolute value is by itself. There's nothing else over here like a +2 or something. Then we set up two equations. One positive and one negative, because we have to see which one is it going to be. So we're going to set the inside -4 plus 5x. This can be positive 16, or -4 plus 5x can be a negative. So because the inside can be positive or negative, we have two equations to solve. So let's do it. Just like we solved all the other ones, we're going to first get rid of the -4, this hanging fruit here, by adding it to both sides. And you get 5x equals 20. And we know this is multiplied by x, so we're going to divide 5 by both sides, and you get x equals 4. So that's one solution. And put our x in there. Now we're going to do the same thing over here. We'll add 4 to both sides. And you get 5x equals -12, and divide by 5. Remember, fractions are okay. Now, I'll show you, I'll prove it to you that it works. We're going to plug in both of these to the original equation. So let's try -4 plus 5 times 4. -4, 5 times 4 is 20. -4 plus 20 is positive 16. The absolute value of positive 16 is positive 16. Remember, the absolute value is always positive. Let's try the second one. Plugging it into our original equation, -12 over 5. These 5's divide out, right? And you get -4 minus 12. Oops, that should be positive. -4 minus 12 is -16. What's the absolute value of -16? Positive 16. Remember, it's always positive. So that's it. Big old smiley face. You have two possible answers because what is on the inside of the parentheses can be positive or it can be negative. The inside of the absolute value bar, sorry, not parentheses. Let's try another one. So step one, remember, was to get the absolute value all by itself. Well, this one has a -5 with it. So first we need to take care of that. That's a multiply by 5, so we're going to divide both sides by -5. And that will get us our absolute value by itself. This will be a positive, let's see, 23. Now the absolute value is bars are by themselves, so we can write our two equations. 3 plus 4k equals 23, and 3 plus 4k equals -23. So the positive and the negative. So let's get 4k by itself. This is a positive 3. We'll subtract it from both sides. 23 minus 3 is 20. Divide by 4. K equals 5. See what we get over here. Leave the 4k alone. Subtract 3 first. This is -26 divided by 4. And we can reduce both of these by 2. Right? We get -13 over 2. So let's check it. We're going to plug these in to our original equation. So negative 5, absolute value, 3 plus 4 times 5. Okay, remember our PEMDAS or GEMDAS. Absolute value bars are a grouping symbol. So we'll do the inside first. 4 plus 5 is 20. 20 plus 3 is 23. The absolute value of 23 is 23. Since this negative 5 is right next to the absolute value, it means to multiply. So you can think of it as a parentheses in that case. Negative 5 times 23. Let's see, you can use your Desmos. I'm kind of doing it by hand here. It's 115. Yay! All right, the second one, we're going to plug in negative 12 or negative 13 over 2. See if we still get negative 115. We should, if we did this correctly. All right, 4 times 13, because I'm just going to do top times the top, bottom times the bottom. Negative 52 over 2. Wow. This is getting a little hairy. I kind of want to get my Desmos out. Wonder if we should. Hold on. Let me write this down. All right, let's grab our Desmos. So we had the inside was 3 minus 52 over 2. Ah, that's negative 23. All right, so let's go back to this. So the inside is negative 23. Being promising. Hey, what's the absolute value of negative 23? Remember, it's always positive. So it's 23. And we know negative 5 times 23 is negative 115. Let me show you on the calculator how you can do absolute value. Oops, why does it always do that? You can just type ABS if you want, and then put the number in. It'll give it to you. Let me see if there are any bars. I don't think there are. There might be. Down here. Ooh, look. There's a button. Wow. So you can also do that. I just knew the shortcut, but you can also do that. So you can use your Desmos calculator as your tool. All right, another one. Step 1 is to get the absolute value bars by itself first. So this is divided by 8. We can multiply by 8. Or you can think of it as 1 over 8 and multiply by 8 over 1. Same thing. These divide out. So we get 7p plus 4 equals 24. Now that you have it by itself, we're going to have two equations, the positive one and the negative one. And we'll solve. And by now, you're probably feeling like an old pro, right? To get the p by itself, we'll subtract 4 first. And that's kind of the fun beauty part of this, is like everything is the same. It's just that the problems start off a little different, but the process is the same. This is where I start to make mistakes because I start talking to you guys. Okay, hold on. Minus 4. Okay, let's divide by 7. P equals 20 over 7. Okie doke. Now the next equation, we'll subtract 4 from both sides. Negative 28. And that's negative 4. I wonder if in these cases you always get like one whole number and one fraction. I wonder if that's a thing. Should look that up. All right, we're going to plug it into the original equation. So I think I should show you on Desmos, since we pulled that up. And let's see if this equals 3. I'm going to write it on my paper because I will forget it. Did I write 17? Oh, no. This is the absolute value bar. I was like, what? Okay. 7 times 20 over 7 plus 4 over 8. Does that equal 3? Let's see. You can kind of do it step by step, or you can put the whole thing in if you're really careful. So I can do the absolute value bar, and then 7 times 20 over 7. Be really careful. Like I need to arrow over now. Close that parentheses. Add the 4. Close the absolute value bar. And then divide by 8. So be careful. Make sure what you have in Desmos matches what your paper is, because one wrong keystroke and you think Desmos is right and it's wrong. Be careful. Okay, we got positive 3. That's amazing. Let's try the second one. So we're going to plug in negative 4 this time. 7 times negative 4 plus 4 over 8. Does that equal 3? Let's go see. Put it here. Negative 4. Woo! It equals 3. We get the same thing. 3 equals 3. Checks out. All right, one more. Step 1, get the absolute value bars by themselves. So we'll add 5 to both sides, and you get v plus 8 equals 7. So then you can set up your two equations, positive 7 and negative 7. Remember, that's because whatever lives on the inside can be positive or it can be negative. And we don't know what it is because we don't know what v is. So that's why we have to see the two cases. So we'll subtract 8 from both sides. V equals negative 1. Subtract 8 from both sides. And V equals negative 15. All right, we'll plug them back in to the original. I think we can do this one, right? Negative 1 plus 8 is 7. The absolute value of 7 is 7. It's positive. 7 minus 5 is 2. Nice. All right, the second one. Negative 15 plus 8 minus 5 equals 2. Does it equal 2? Negative 15 plus 8 is negative 7. Absolute value of negative 7 is 7. It's always the positive. And sure enough, 7 minus 5 is 2. Big happy face. Party hat if you want. I just think it's so fun to be able to check your work and see that you got the right answer. Because it's like right there in front of you. I wanted to show you all something. Let's put this into Desmos. V plus 8. See, I'm already going to forget. V plus 8 minus 5. Okay, let's try this. Just to kind of show you where we're going with this. Actually, we have to use x. All the variables in Desmos when you're graphing is x. But it's the same thing. It's going to be v and x are just letters, right? Look, I already forgot. Was it plus 8? Hold on. Yes, minus 5. Let's close the bar. Equals 2. I wonder if this will let me. Well, it's so. Hold on. I wonder if this will be better. I'm going to put 2 on the other side. Yeah, there we go. And this is what an absolute value equation looks like. And the whole deal about the two, having the two different answers, because it goes up into the two different directions. Like that's the whole reason it does that. It behaves that way. It has a negative piece and a positive piece. And there's the solutions we found, right? Negative 15 and negative 1. There they are. Negative 15 and negative 1. It's where the line crosses the x-axis. And that's so cool. And this is what we're going to get to when we start to analyze functions, and we get to see where functions cross that x-axis and what does that mean. But I wanted to show you what the absolute value looks like on the graph, because it's just so cool, and it's so neat to see like, oh, this is the negative piece here on the left, and then this is the positive piece. So lots of fun to look forward to. Thanks for hanging with me. I will see you all this week. If I see you on Wednesday, then I'm looking forward to seeing you. My Thursday kiddos, I'm going to be out on Thursday, and so Miss Gilner is going to be covering for me. I'm really excited because she's an amazing math teacher, so you guys will be in great hands. And I'm also sad because I will miss seeing you. But I'm just out Thursday, so if you need anything, I'm here Monday through Wednesday and Friday. So please reach out. I know a lot of you are starting to think about retaking, not a lot of you, some of you are thinking about retaking the Unit 1 test. So I'll be getting back to you today about that. So I hope you all have a great week. Bye, everybody.